Okay, so today we're going to go over quadratic functions using the vertex form. There's two different forms when it comes to quadratic functions. One is standard, which we'll talk about in another video, and the vertex form, which is very similar to absolute value, which we just went over in class. That's where we're kind of leading off with the vertex form. All right, so we're going to do a parent function, and we're going to build on from there to go over what happens with the vertex form. It makes it actually very easy, very simple to graph. The basic parent function, the very first function, is just y equals x squared. All right. The fact that it's the square root of 2, and we square the x, that's what makes it a quadratic. If it had another exponent on there, it would not be a quadratic equation. If I took away the 2, it would just be a linear equation, x equals y, which would be a straight line. We're going with quadratics today. All right, so let's see the basic shape. So the easy way to create a graph is create an x and y data table. We're going to use some easy inputs, and then we're going to plug the x values in for x. Then we're going to solve for y to get our outputs. So we'll do 0, 1, 2, 3. We need some negative values. We'll do -1, -2, and -3. All right, so if I plug 0 in for x, 0 squared is 0. That's easy. If I plug 1 in, 1 squared is just 1. If I plug 2 in, 2 squared is 4. If I plug 3 in, 3 squared makes y equal 9. And it goes the same for the negative values. If I plug in a -1 and I square it, it means -1 times -1 just gives me a positive 1. Same thing with -2. -2 squared would be positive 4. And then -3 squared is a positive 9. Now that I have my 7 points on here, let's graph them and see the basic shape of what a quadratic function is going to look like. Let's use red. All right, so 0, 0. We'll go right there. 1, 1. Over 1 on the x-axis, up 1 on the y-axis. 2, 4. And 3, 9. And I do my negative sides as well. So -1, 1 goes right there. -2, 4. -3 and up to 9. There we go. And then we just draw it. Now it looks kind of like a V, but it's actually a more rounded shape like a U. Yeah, if you're familiar with absolute value shape creates like a V. This is more like a little bit rounded like a U. And it actually has a special name for it. Sorry, my phone just interrupted me. Siri was trying to talk to me. I guess she likes quadratics. Let's say, so this shape actually has a name. This shape is called a parabola. What's cool about the parabola is it's symmetrical, meaning it's a symmetrical shape. It's the same on one side as it is on the other. It's like the mirror image. We also have down here at the bottom, this bottom point right here is called my vertex. That's going to be important. That's going to be important in the future. The point of the vertex is 0, 0. It's the origin for right now. All right. So this y equals x squared is the basic parent form for quadratics. You can graph any quadratic by creating a data table. Once we create it, we can actually graph it. It creates a parabola shape. And the one thing I want to point out right now is that the endpoint, the little peak at the bottom, is called the vertex. When it's at the bottom, it's considered the minimum. Later we'll see we're going to flip it upside down, and then the vertex will be the maximum. All right, so let's change things up a little bit. Let's start adding stuff on and building out into the vertex form. So let's use y equals x squared, I don't know, plus 3. All right, so So we're going to have the same basic shape because it's y equals x squared. This plus 3, just like an absolute value, will cause the parabola to move up and down on the y-axis. So we have a number outside. This number, oops, there we go. It causes it to move up and down on the y-axis. Moves up or down on the y-axis. So just by knowing that little piece of information, I can actually graph this without even doing a data table, as long as I use that same basic shape of a parabola. So my original point was 0, 0 as my vertex. I'm just going to go up 3. So we go up 3. There's my new vertex on positive 3. And for now, I'm just going to use the same basic shape. So y equals x squared plus 3 just moves it up a little bit on the y-axis. All right, and if I was to make this a negative 3 or negative number, it would move down. So if I change this to a negative, say negative 4, same rules apply. We're just going to move down on the y-axis from the original point. So my original origin for the parent function was on the origin 0, 0. Now it's a negative. I'm going to go to down 4. Put my new vertex down there. And then draw in. That wasn't the best parabola, but just going to move down 4 and draw in my normal parabola. Later on, we'll discuss what makes the parabola wider and more narrow. But for now, we'll just use the regular shape because we're going over the vertex form. All right, let's see. What else can we change up? Let's do y equals a negative x squared plus 5. All right, the only thing different here is I have a negative out front. So that negative is going to take my normal parabola shape and it's going to turn it upside down. So I would still use the number on the outside, the last number, as my starting point. So I'm going to go up 5 on the y-axis. So I'll go up 5. Now, instead of drawing my normal parabola going up, it's negative, so I'm going to draw it the same shape, just going down. There you go. So the negative just causes it to flip upside down. All right. What else? Oh, by the way, this is still the vertex. My vertex now is still 0, 5. That's the point it's at. And now the vertex is actually considered a maximum because it's the highest point on the parabola. All right, let's move on. Remember, if you're in my class and you're taking notes from this video, you can always hit pause, write down what I have on the screen, and listen and rewind it and hear me talk about math one more time. All right. Y equals, we're going to do in parentheses this time, x. We'll do minus 4 squared. All right. Last time we had the exponent of 2 actually on the x, and we had a number on the outside. Now, we still have an exponent of 2, so it's still a quadratic. All we're going to do now is we're going to find out what this number does on the inside. And if you're familiar with absolute values, the number on the outside moves it up and down the y-axis. The number on the inside moves it left or right on the x-axis. So let's fill that out. So this number on the inside moves the parabola left or right on the x-axis. But just like in absolute value, it moves in the opposite direction. So we go opposite of whatever that number says. Because if you think about it, -4, you're thinking we're going to move in the negative direction. We don't do that. It actually moves in the opposite direction. So here, instead of moving in a negative direction, we're going to move in a positive direction 4 units. I'm going to move over 4, put my new vertex right there, and just draw in my normal shape for right now. Of my parabola. All right. And while we have this on there, since we're not directly on the y-axis, I have another piece of information I want to share with you. And by the way, if that was a positive, we would actually move the other direction. So what we're going to do here is I'm going to draw in a vertical line that's going to go directly down through the vertex. So we have a vertical line. This vertical line is called the axis of symmetry. All right, that's the axis of symmetry. And we're going to use that a lot in future things we're going to do with quadratics. The axis of symmetry is a vertical line that goes straight down through the vertex and divides the parabola perfectly in half, symmetrically. So if you notice, the left side matches the right side. All right, so the axis of symmetry is indicated by the x value. Because any kind of vertical line, single line, up and down in the graph is always x equals something. In this case, it's x equals 4. Because no matter where we are on that line, x is always going to be 4. So that's our axis of symmetry. All right, let's move along. Let's actually include one on the inside and on the outside. And see what happens there. So we go y equals x. Let's go positive 5 squared minus 3. And it's positive overall. All right. By the way, we got Scooby-Doo helping us out today. Thanks, Scoob. He only works for a couple of Scooby snacks. That was actually compliments of one of my students of mine who actually do it on a day when I was out of school. All right, so let's do this. First thing we want to do here is we want to figure out where we're going to move the vertex of our parabola. So here, this moves left or right. We always go in the opposite direction. So we're going to go in a negative direction. So we're going to go left. We're going to go on left 5 in the negative direction. Then this is going to cause us to go down. It's a weird looking, there we go, down 3. Because the number on the outside is not opposite. The number on the inside is the opposite direction. All right, so let's graph this so far. We're going to talk about the axis of symmetry and the vertex and see if we see something there that might match up. So left 5, 1, 2, 3, 4, 5, and then down 3, 1, 2, 3. And put my new vertex right there. I'm going to draw in my basic shape. Now later on, when we actually start using data tables, we'll be much more accurate with our shape. But for today, we're just using the vertex form so we can kind of match up. If we ever have a problem on a test or an assignment, we have to match an equation to a graph. It makes it much easier to actually match them up. All right, so it goes left 5, down 3. So my axis of symmetry I don't run out of room. There we go. Would be x equals -5. Right? Because it's the x value. That would be the vertical line that goes straight through the vertex. X equals -5. My vertex would be, in this case, it's the ordered pair that that vertex is on, so it'll be -5, -3. All right, -5, -3. Now, do you notice anything similar? Do you notice any patterns here when it comes to axis of symmetry in the vertex? Yes, hopefully, and people in my class actually noticed this. They noticed that the x value in the vertex is the axis of symmetry. They're always going to be the same. So yes, your axis of symmetry is actually just the x value in the vertex. So once you find the vertex, you have your axis of symmetry and you have your entire vertex. So that's one thing. The second thing, if you've noticed, and this is actually why this equation is called the vertex form. If you just look at the basic equation right here, in the basic equation, it tells you what the vertex is. We pull the opposite number out of here for our x value, -5, and then we keep this true, -3. So that's why this equation is actually called the vertex form. All right. Now, there is an actual form that has all numbers in there, all variables. And what that is, in case you come across it, is going to be this. There we go. It's gone. Now, this will look crazy at first because it's all variables. And students go, wait, what's that? But yes, once we start plugging in some numbers, it'll make a lot more sense, especially with what we've already gone over in class. All right. The actual vertex form would be y equals a x minus h squared plus k. That's your actual vertex form without any numbers in it. Now you notice, why are they using an h and a k? Well, they've already used an x and a y. So even though the h is how we move things on the x-axis, and k is how we move things on the y-axis, they can't use another x and another y. All right, so they use the h and the k for the variables in this case. So these two numbers right here are always going to be your vertex. So your vertex is your h and your k. Now remember, we always use the opposite. So that's why we go the opposite direction. For example, if I was to use, as an example, say I use 2, 7 as my vertex. And I want to plug the 2 into the equation. Notice right now it's a positive 2, because that vertex would actually be over 2 up 7 to be right here. Right? And then I guess that would be my parabola. But notice if I plug 2 into that equation, it actually says x minus 2. So that's really why we go in the opposite direction. And then the 7 here for the k would be true to form. All right, now, what does the a do? The a is a little different. The a, we actually did use in our examples, but we used a, we let a equal 1. That's why we kept the same shape of the parabola. The a is a number that actually determines how wide the parabola gets or how narrow the parabola gets. So the a, the value up here, determines how wide or narrow the parabola will be. All right? So this number up there, if there's a number up there, it's going to determine how wide or how narrow it's going to be. If it is a fraction, so let's do burnt orange. I don't know why, but let's do burnt orange. So if the number up front is a fraction less than 1, like 1/2 or 1/4 or 1/5, anything like less than 1, that means it's going to be a much wider parabola. All right, it's going to be wider. So you're going to have your vertex. It's going to be a very wide parabola. All right. If the number is, let's use green, I guess. I haven't used green on this board. All right. If the number is greater than 1, like say 2, whoops. There we go. 2, 3, 4, whatever. So if it's greater than 1, it's going to be a much taller and more narrow parabola. All right, and the higher the number gets, the more narrow it actually is going to get. All right, so those are the basic functions. Oh, if you want to see one with a numbers in it, let's do this. It won't move up. Get rid of this. Boop. Actually, let's do that. Let's do one more, just to kind of give you an example of what we're talking about. And we don't need this right now because we're not going to graph on this one. We'll actually graph in the next video. All right, so if I gave you an example of a quadratic function in the vertex form with all the numbers in it, including an a, it would look like this. Y equals 1/2 x plus 4 squared minus 3. All right, and just by looking at that, I know my vertex is going to be opposite on the inside for the x value. It's going to be -4. True on the outside. So my vertex will be -4, -3. My axis of symmetry will be a little lazy today, right? Axis of S. Is going to be my x value. So x equals -4. And since it's a fraction out in front, I know it's going to be a wider graph, or a slightly wider parabola. All right, that's what we covered in class today. Hopefully this is going to help you out. If you have any questions, please ask me in class. Otherwise, I will see you tomorrow in school.